Yesterday, or maybe it's a few days ago, I received an email that's about the topic of AI energy usage. And based on some recent studies and graphics, it seems that the usage of AI, previously thought to have a great impact on the energy consumption and the environment, turns out it's not that much. And when you look at the figure, it seems that everyday usage of water, like taking a bath, is significantly more usage of water than one query of ChatGPT. And the whatever it is, I think the diagram was about the Google Bard and ChatGPT compared to the environmental impact of making dairy products was pretty much negligible. So maybe all this fear around, oh, is AI consumption destroying the planet, maybe we don't have to be that afraid, or maybe we don't have to feel that guilty. That was sort of the overall sentiment regarding AI and the energy usage of AI. Of course, the email went on to a different tangent about the human creative tendency regarding the usage of AI. But I think you could definitely look at AI usage in that lens, but I think that is missing some greater points that the person outside of technology might not be familiar with. And although I am leaving the world of software engineering, I have been in it for the past decade or more. And in particular, I have been in the world of big data for a very long time. So, with this episode of the podcast, I wanted to give you a little bit more insight into what is really meant by the impact of AI. And let's start with the fact that number one, the main energy drain of AI doesn't really come from answering queries. It actually comes from training. And so just looking at the, consumption for queries is missing a bigger part of the picture. Now, some people, when they do the argument, when they form the argument that AI usage isn't that much of an energy drain, they say, well, training is a sunk cost; it's already done, and whatever queries we answer, that's where the usage has to be measured. That does have a point, but the thing is, no company is going to simply just stay at one model of the language model, large language model generating AI, right? So we know that, hey, GPT, something dot something is in, coming in preview, and if you pay for it, you get early access to it and such. But we have to understand the the model numbers of the LLMs that we see are outputs that have already been tested and compared against with tens of alternatives, and it was deemed good enough to release to the public in an experimental fashion. So that means for every version of the LLM that we see in the public, there are going to be many, many discarded versions of the LLM that was not satisfactory enough. So yes, it is a sunk cost, but that sunk cost will be repeating as long as people keep using AI, as long as there is a market demand for it. And to understand why the training is so much more energy intensive, and to understand how it might be a little bit more energy intensive or differently energy intensive than you might know, you have to understand the how the field of AI or generative language models came to be. So, in my honest opinion, as a personal opinion, I think it is already bogus that your generative AI query spends energy. So why this is Traditional machine learning models was based on mostly statistics. So we needed to have a hypothesis, we needed to have a statistical model, we needed to input the parameters in order to train the data over a very large data set. And from that, you would look at all the data, you would look at all the possible combinations and the statistical variance. But the thing is, once you have the model, it was trivial, relatively, to give you the result. And that is because traditional machine learning models solved very specific problems, like classification. So a very easy example of this is the handwriting digit recognition. So given this, what number is this? So this is a classic classification problem, right? And there are other classification problems, like, um, you know, 1 to 0, 0 to 10, no, 0 to 9. That's one option, but true, false. Or based on some, input, we have to make a rational output. And so these are called like decision trees. So you have these kind of classification problems, but also you have like an approximation problem, right? So, hey, given this, what's the most similar output compared to my input? So you have that, and you have basically traditional traditional machine learning at its peak is like speech recognition. Given this waveform, given that this is a language, a specific language, for example, this is English or Korean, given this sound wave, what do you think this means? What do you think this is? So you look at two things, right? So you look at the audio file and you get the most likely phonemes. And then from that phoneme, you look at the language model, which is like purely, token and language based. It has nothing to do with audio. So you mix in these two distinct models to generate what the most likely said thing is. So that was like at the peak of the traditional machine learning. But again, even those, once you made the statistical models after a painstakingly long time and expensive process, you provide the input data and then it would give you the result, because now there's no more guesswork involved. You just follow the tree. Oh, it's based on the first thing, it's probably this, and then it just keeps on going in a forward fashion. So machine learning giving output is relatively trivial. It almost should be very little energy to generate a result. And now we have to understand that this is probably because the problems that the model is trying to solve is very limited in scope. Then came generative AI, which kind of can do everything, right? So because of this, not only do you need to train a greater amount of data to cover all cases, because you won't ask a speech recognition engine to draw something, right? But generative AI models like ChatGPT, you gotta be able to recognize speech, but you also need the ability to generate images, and then you need to also be able to code. You need to also be able to draft emails, and so it needs that amount of expansive training data sets. Along with that, now even the results, even after you have the final model, to go through it and generate the results, it takes electricity. So yes, the 99 to 1 ratio, this is my hypothetical example, but like the 99% of the energy consumption will be in training, and 1% of it will be during actual answering. That still follows, right? But if of if your usage of ChatGPT is akin to already like full 2 hours of bath, Now, imagine what 99 times that would be like. And that's just for one language, right? And so think of all the computes that you need to do in order to do that and how much electricity it would use. Okay, but the thing is, sure, but it does serve some utility and it's good and it does a fairly good job at things, which I'm not going to argue with. But the thing is, now, if we have that much data to train, right? It needs to exist somewhere, which means there needs to be computers that hold on to that data, right? So your hard disk has some terabytes of, disk storage. So imagine if you have 10 people's worth of data across all of their internet usage. Now, that will not likely fit in your one computer. But so now this is why people buy digital storage, right? And even with that digital storage, people keep running out of storage. And that's probably due to like the psychological factor of like us wanting to hoard onto everything. But you keep growing and growing, and then think of how much data you think of the size of the data that you will have in order to train these massively large data sets. And more importantly, think of how many computers, think of how many data centers it needs to be able to hold on to that data. It's going to be a great amount of compute just to keep the servers on so that the data is accessible. Now get this. There are faults that happen in data centers, right? Electricity might randomly go out. Some data centers catch fire. These are things that happen because data centers are physical locations. Which means if all of your data is just stored once, it will not be fault tolerant. And data is very precious, as you can see by this point. So, in order to make things fault tolerant, companies will replicate your data. And because data scientists are also spread all around the world, your replicated data sets will travel across the world, which means there needs to be networks that connect continents, which means with more cross-continent travel of data, you need to make more pipes, you need more wires, and you need to build more data centers. So even if you're not training your data just by holding onto it and replicating it and making sure that they're available all the time, this is already just to keep the lights on. It's an immense amount of electricity and energy usage. And now, on top of that, we have the introduction of societal issues. But before we get into that, let's quickly recap everything that we talked about so far. So, even though the usage of ChatGPT, or even if the usage of data, large generative AI models might not be as much of an impact as you thought, it is already a significant amount of increase compared to traditional machine learning models. But the thing is, we have to acknowledge that generative AI models are much more powerful than the traditional machine learning models, which are meant to be very limited in scope when it comes to what kind of problems it will solve. Now, training the old models were already across distributed computing platforms. And, when I used to work at a search engine company, people used to kick off the job and then come back a few days later to look at the results. That's how long it took at a search engine company that had lots of computers to work with. And now imagine that times however much. And so to hold on to that data, even if you're not computing, even if you're not training, you need that much storage, which requires that much electricity, and it will heat up. And so to cool it down so that the data centers don't catch on fire, you're going to need to spend water. And you're going to need to replicate the data so that it's not so that it is fault tolerant. And then to do that, you're going to need to be making a lot of data transfers. And so the environmental impact of just having generative AI is already very non-negligible from a planetary standpoint, I think. Okay, and now we get to the societal impact. The thing is, traditionally, we used to use our computer's RAM to do the training. RAM and CPU. RAM is random access memory, and it's basically compared to, I'm gonna talk a little bit about old time computing. In old time computing, in order to read the data and then do some operations onto it and then write it back, you needed to read the data from the hard disk, which was literally like a spinning disk. And then needles would move around it, and then it would read in the data. And in order to do the compute on it, it needs somewhere to stage it. And that staging area is the RAM. And so why the RAM is good is because the RAM is like a chip. It's like it's very fast. There's no disk. It doesn't have to spin. It's already connected, and whatever electricity flows into it, it's like sensitively read. It's like an on-off switch. So you read the data, which is an expensive operation, but you load it onto the RAM, and then inside the RAM, you're ready to compute something, add something, subtract something, divide something, multiply something. And that actual operation is done by something called the CPU. And olden days, there used to be one CPU, but nowadays we have like 4 core, 8 core, 16 core. So that means we can do 16 operations at once now if we have a 16 core CPU. If we have 8 cores, we can do 8 operations at the same time. So the RAM is used as a staging environment, okay, and the computer is done. Now in order to write it back so that it stays somewhere, because RAM is a very electricity dependent thing, if your computer goes out of power, whatever is going to be in the RAM is going to be lost. So this needs to be written up somewhere, and that is now going back to the disk, which is an expensive operation. So in this kind of a working model of computing things, like I said, training machine learning models is about math, is about statistics, which means there's a lot of compute to do. But even the most expensive CPUs have some number of CPUs, right? Some number of cores. But you see, given the great amount of data that you need to process, CPUs are very inefficient because you need to wait. So this list of things to do needs to be read sequentially. So yeah, you can work on it 8 at a time, 16 at a time, but the thing is, it's very difficult to parallelize the work done by CPUs. So this was the very limiting factor of machine learning and AI development in general, until a technology called graphic processing unit came about. So GPUs are meant for literally graphics. But the funny coincidence is that modern graphics is also based on a lot of math. Because there is this thing called ray tracing, which is basically simulating a ray of light and then make it bounce all over the place, and then it's gonna calculate the angles, and then based on the color and the shade, and based on the color that the objects have, and how is it gonna reflect and refract and all of that. So that became a math model on its own. So in order to solve these complicated mathematical models, turns out you could use these things in math called linear algebra, because everything can be represented as matrices. And the nice thing about matrices is you can parallelize the computations. And so the graphics processing unit developers developed hardware dedicated to improving graphic processing. And that meant with the expensive GPU, you have a lot of math problems to solve in order to make something appear on your monitor. They can be solved in parallel, and it can run very fast. And someone had the coincidental idea of, why don't we use GPUs to do this kind of a calculation? Because there's a lot, and we can benefit from parallelizing the work. And so came the boom, big boom of AI. Because now, with a lot of GPUs, you could significantly divide up the work. The electricity usage of that aside, this gave rise to an interesting phenomenon. Now, companies started hoarding GPUs. And not only companies, but underground government-based hackers, or people or like organizations that have had a vested interest in developing their own solution of models, AI models, started amassing GPUs to the point where now the average consumer has to buy a extremely disproportionate amount of money for GPUs. So I bought a computer recently. So all the other parts are like reasonably priced, but then GPUs are, compared to what the price of GPUs were before, now GPUs are just priced like this. And the only reason behind that is AI. So now this kind of a market disruption around previously existing products, GPU, I think, is now this is my personal opinion, but GPUs, I believe, will be just the first. There will be more commodities, there will be more parts that turned out to be beneficial for the development of AI, and they will likely be hoarded again. And this impact, unfortunately, goes to the consumers. So many companies recently are aware of this problem, and they are making sure to develop their own hardware dedicated to machine learning, so that they are less dependent on GPUs. Because now the other problem is that because one or two companies have practically a monopoly on GPU, so much of their model outputs and so much of their work depends on these two GPU companies. And so because of this, it has become kind of a power game that people don't like to participate in. So now they're coming up with their own set of AI chips. But this means now everything I explained is from the perspective of one company, right? So now if we have 5 competing AI chip and hardware companies, they all need to benchmark by training their own datasets, right? So that will spawn off another energy drainage. And this is, I think, the real systemic kicker. Because just like how the end consumer who wants to just play a nice video game now has to suffer because of AI, the impact of these things are largely driven by the companies. They get to make the playing field, and it is the consumers who have to carry the burden of everything. So many people argue about why we need to cut back on our AC usage when there's corporations that burn money like it's nothing, that burn energy like it's nothing. So, just like that argument, the bigger the playing field and the competition of AI becomes, the more the end users will lose. And now, there's a lot of criticism about people using AI recklessly. And it is likely that, when AI becomes more powerful and more, popular, people will want to use it more. So, on one hand, people criticize it and then AI usage goes down or it gets severely regulated and limited. Who does this impact the most? The people who really benefits from AI from an accessibility standpoint. I got into the field of big data through speech recognition and speech synthesis. This is immensely helpful for people who cannot hear. And if regulations hit AI so that it just becomes kind of like, policies, it tends to completely neuter a field when it's, in response to a, big consensus. The most likely hit will be the people who use AI for accessibility purposes. And even if it goes the other way, if it becomes massively too popular, which means at some point it will likely be monetized. Again, this is my opinion. And so the people who need to use it the most but can't afford it will again likely be people who are disabled or people who need AI for accessibility purposes. And so it's this classic case of the people and the organizations with capital creating an uneven playing field, ultimately to fuck up the people who are at the most risk, people who are the least powerful. And this is already kind of easy to see by just observing. Are there any powerful AI companies outside of the United States, outside of the what we call already powerful companies? There's no, powerful AI company in Bangladesh or Myanmar or Guinea, or Gabon, simply because this is a money game. And when we use AI, if we just look at electricity, I think we are missing the bigger picture of how the energy imbalance goes. Because at least when we are using electricity for ourselves, it tends to serve us in a simple way. It makes us cooler, it makes us warmer, it feeds us, or it has some kind of a direct impact on us. It has some kind of a direct benefit on us. But the usage of AI and the continuing to make it bigger and continuing to make it more powerful ultimately ends up not serving us, in my opinion. Which relates to this other point that I wanted to bring up. When we use water, when we use resources for food, for other things, it tends to recycle. And one of the big problems with modern society is because around food. Food is using a lot of preservatives these days and a lot of growth hormones that leave a lot of there's a term for it, like the heat exchange ratio makes it very inefficient, but it makes you full because the food engineers design food that way. So that means when you ate something in the past, either you used up a lot more of the energy that came from the food, and more importantly, the food that you pooped out was able to be used as a fertilizer because it contained a lot more calories. But nowadays, because of the preservative and things like that, it is, I read that poop is now useless because it is filled with preservatives and it doesn't really do anything for the agriculture. So we have a lot of by waste that doesn't really resolve itself, that doesn't really dissolve, just like microplastics. And in order to clean up the microplastics, how much energy do we have to use? So just like this, I think of the electricity that and the water usage that goes into generating a model. And I can't help but think, is that energy ultimately going to be reusable? Because I look at the ChatGPT, subreddits, and it's like I made it generate 100 images of the Rock, and that whole time where people were generating, the Studio Ghibli kind of art. So after about like 5 minutes of entertainment or like a few weeks of entertainment, that energy it's just like, okay, what purpose does it have outside of just being used? And now this brings up an interesting point about, then does everything need to have a point? So does energy used for entertainment, is it ethically wrong to be entertained? So it does bring up that kind of black or white argument, but I'm not gonna say that your entertainment is not worth the energy. But why are we against billionaires renting out entire islands? Why are we against generally people flying private jets to travel 20 miles? Just because you can, if everybody does things you can, then we just end up messing everything up for ourselves. Just because I can have a fireworks that just burns the entire, just because I have the resources to buy that much fireworks doesn't mean it's a good idea for me to do so. So I think we tend to spend a lot less time thinking about how this usage ultimately ends up impacting the flow of energy as a whole in this planet. And moreover, the systems that occupy this planet. It keeps on making the powerful more powerful. It keeps on making the powerless progressively less powerful. Because it's just a human tendency to keep doing it like that. And these are kind of like the economics and the social aspects of it. But I think another social aspect that's more important is how it affects the psyche, how it affects the human mind. When you rely on ChatGPT, it's very convenient, I'm not gonna lie, based on the experience that I have had in the past. But this convenience is something that really ultimately ends up draining your personal power. And based on the books that I have read recently, the more prominent one I've read was the book Crave. by Dr. Raphael Cuomo. And in that book, it describes how the dopamine, the natural process of dopamine, is really centered around something that you covet, something that you want to get. But the process of obtaining it is a natural part of the biologically natural mechanism of how dopamine is derived. But nowadays, so much of the gratification and satisfaction is instant. And because of that, the natural flow of getting dopamine from your mind has become very disrupted. And now the disrupted state has been accepted as the new norm. Therefore, when you have a craving and you can't resolve it, it's much more paralyzing than what it used to be. And on a larger scale, that's what AI usage kind of does to people. Because yes, you could sit around and thinking of a new draft of how to write this email or write this technical document, or you could just write it in 5 seconds using this prompt. So because of this convenience, the more you are tempted to use it for challenging things, you're likely not going to use ChatGPT for easy things. You are going to likely rely on it for harder things. And again, because of that, you will more and more lose the ability to do difficult things. And as a Buddhist life coach, this is already the biggest blocker I see from people, the inability to do difficult things. And it will only get worse from here. So, this is something I ask myself at the dentist every time I go. Was it really better to just not have flossed if it meant this much pain? Because when I think about flossing, I'm like, whatever. I'll take care of it at the dentist at the next cleaning. But turns out it's an extremely painful process that makes me regret it every time. So that's why after a certain point, I just decided to floss every day. So, just like this, you're having, the more you rely on ChatGPT or AI for difficult things, the more you are setting yourself up for a bigger inability to do anything difficult. And this, I think, is the greatest energy sink that we may not be taking into account. And I think I talked about this in one of my previous emails, but when we are hiring, now it's very difficult to find a candidate who is as good as their resume. Why? Because resumes are amazingly good now thanks to ChatGPT. But at the same time, verifying and proving that the resume is real is very difficult because now people can't really interview without ChatGPT on the other window. And this is what really inspired this podcast episodes today. Now, companies want to look at your screen as they interview you so that they know you're not using AI. But this has a much greater impact than I think what meets the eye. This means now the invasion of privacy has been one step more normalized. Now, the thing is, I'm not the biggest privacy person. But even with my kind of a standards on what, the right amount of, privacy should be, normalizing other people seeing my screen, I think is not really the ideal direction society would need to go. Because what would happen as a result? It's already happened because I saw an Instagram reel of somebody just pasting a sticky onto their laptop screen and putting their phone right on it, and then the speech recognition works on the phone, and then it just generates the answer, and then people just read it like this, as if they're looking at the screen, but they're looking at their phone. So in order to counteract that, people will start to want a camera behind you as well. So when you just look at the progression of this, the more and more the lack of privacy, especially for online meetings, will be normalized. And again, this ends up ultimately hurting the people who are mobility challenged and technically challenged. Because what if you're a relatively older person who's trying to start something with the technology, but now there's this even bigger hurdle that you have to go through, and you have to give up your privacy as well. And this feeling of constantly being surveilled, this feeling of constantly being watched will incur another set of energy costs and such. So, all of this to say, if you use AI, I don't think it's a problem with you. I personally have a very, very strict no AI usage rule for my life. I never use AI because I have a personal stance against it for all the aforementioned reasons. But I don't judge you for using AI. How can I? When, like I said, it's the systems that keep shoving it down your throat. And it always makes things that are very mass appealing. It makes you easier to blend into the societal norm of what looks good, what passes as good. And who among us doesn't want to be good? So it's feeding off of these types of human tendencies and desires. And in the process, it makes itself richer and bigger. And with its acquired power, it makes itself even more bigger and bigger. So, in a nutshell, this is electricity, this is ethics, this is the human mind, power of the human mind capitalized. And if we don't see this system, how it's working against us individuals and communities, we can't really stop ourselves from using it because we're not seeing the whole picture, we're not seeing the whole problem. So, in order to make changes to AI, it will likely not be possible with individual willpower. It will likely need regulations. It will likely need social contracts from the government, from consortiums and things like that. But ultimately, those all derive from individual intent. So, my hope is, number one, I hope you understand through this episode that it's not your really problem that you're using AI. Number two, but the usage of AI does have a significant, or you know what, non-negligible impact on the environment. Number three, not only the environment, AI usage and the continuing development of AI exacerbates already existing social problems that are already driving us to the brink. And that is my full thought on the energy consumption of AI.